Good day, everybody. So this lab, this packet tracer we're to be doing is let's identify our network devices. So we have a router, we have a switch, and then looks like 4 PCs. So what I'm going to do is just hover over the router. Now, if you click in anywhere in the white area, that means that you can hover, and then we can see the name, device model, the host name, the ports. Gigabit 0 is down and gigabit 10 is down. Hold the mouse over the switch. It's got the name, device model, host name, ports, gig 1 through 6, 0 through 6, total 7. They're all down except VLAN 1 is up and it has an IP address of 10.10.10.2.24. I could assume the PCs have no IP. The name is the IP address we're going to do statically. Okay, so supposedly this router has a gigabit and we need to put on it an IP. So I'm going to be lazy and copy this. Feel free. First thing you do is look at the port status. So a router by default, always off. We'll paste. I'm going to press tab, and then I want to change it to 24. And we'll adjust 24 when we get to that point in the chapter. All right, so now it's on. So if I hover, I have an IP. Okay, let's connect them up. So here's your cabling. It goes straight through copper. Now, if you hold the control key and click the cable, will allow you to connect multiple devices. So I don't want to do gigabit 0.1. Any port on the switch is fine. Uh-oh, I think we put the IP on the wrong interface. Let's go fix that now, so tomorrow we don't have that problem. Gig 0, oh, nope. Take this off. Well, here, very common problems when we plug things into the wrong port and we forget to turn them on. So now we should see a green light. This one's amber. These devices are having a conversation. 50 seconds later, it'll turn green. So let's connect up our PCs. Go in any order. So predictability, repeatability. Every time we connect, we expect an orange amber light for 50 seconds. And you don't need to remember that. But when you plug into a switch in the real world, how long does it take to turn green? So there's no device here, right? So if we go to any PC, look, the DHCP is not working. So it's using a PIPA 169.254. So let's do static. This is 100. Notice the subnet mask always is the same. There's a logic behind it, and we'll talk about that also at a later time. We don't, oh, we do have a gateway. Get your gateway, you won't be able to get to the internet. We're not doing DNS on this lab. All right. Only make one change and test. So we want to see if these are working now. If I can ping the gateway, 10, 10, 10.1. Sent out 4 received, nope, 4 sent, 0 loss. So we have connectivity between this host and the gateway. Now I'm going to arrow up and I'm going to change it from .1 to .2. This is the switch. This is normally you time out the first ping and then you get 3 replies. That's normal what happens. That's normal operation. We'll talk about that also later. All right. So we got one PC done. Move to the next. Once again, no server. DHCP failed. This is 101. I'm just incrementing by 1 so I don't repeat an IP because it won't like that. Gateway. All right. Once we put in the IP, subnet mask, and gateway, we test. Close this IP config window. Ping 10.10.10.1. Replies. Ping the switch 10.10.10.2. Once again, last time we pinged the switch, we got a timeout, and then the replies came. So to me, that's normal operations. And fourth PC, DHCP failed. We'll make this 102. Put the correct subnet mask in. Gateway. Got our IP in. It's not duplicated. Subnet mask is correct, and our gateway is in. Test. Ping your gateway.1. No timeouts. Ping the switch. You're going to get another timeout. But the next reply is good. It's when they all 4 cents, 4 loss, that's spam. This obviously is not the right IP, 10.10.10.103. Somebody was playing with this one. Okay. Once you get your IP, subnet mask gateway, you're going to test. Ping your gateway.1. All sent, all received. .2. So again, we're going to get a timeout. And then the next 3 will hit. So let's ping 102. That would be the PC up to the left, the 100. This is 10. This is 102. Ping 101. Ping 100. And 103. So actually, I think this is 103, right? So IP DONFIG /all. Yeah, this is 103. So I pinged myself. Remember, the other way you can ping yourself is ping 127.0.0.1. That's a loop back to the NIC card. It will always reply if your NIC card is working properly. All right, so let's quick review. Router has an IP for the gateway of .1, switch is .2. We put in the router statically. Someone put the IP in the switch statically. Each PC is set for static. Okay. And verify they ping. So this is static addressing. So imagine going out and having to touch 1,000 devices to change an IP or a subnet mask or a gateway or DNS. So I like servers in my environment to help me take that load away. So that concludes our video.